Hi there, Mr. Sutton here, bringing you the IM3 Honors 4-1 Part 2 homework solutions on solving quadratics by factoring. For this problem, to solve by factoring, I need to get everything over on one side, so let me add this 60 over to the left side. And now to factor this at all, I notice that I have an a value, a squared coefficient that's not 1. So I'm going to either have to take out a common factor or use the AC method. Now 4 goes into 4, 32, and 60, so I can actually factor a 4 out of all this. That leaves me with an a squared minus 8a plus 60 divided by 4 is 15. And factors of 15 that add up to negative 8. Well, let's see here. 1 and 15 won't do it. 3 and 5 is the only other choice. If I had negative 3 and negative 5, that adds up to negative 8. So I've got my 4 here still. I have an a minus 3, and I have an a minus 5. Setting each of these factors equal to 0, I see that if a is 3, that would zero out that a minus 3 parentheses. And if a is 5, that would zero out this other parentheses. And as far as this 4 out here goes, 4 is a constant. It can never equal 0, so that's not going to give you any kind of solution. It's just these two here. For this problem, we're told that r and s are the solutions to this equation here, and r is bigger than s. Given that, we want the difference, r minus s. Well, basically, we have to solve this equation for k, and then we just have to subtract the smaller number from the bigger number. Okay, well, to get this started, I'm going to distribute this k, and while I'm at it, since this is going to be a quadratic equation, I'm going to move this 5 over to the left side so I can solve it by factoring, hopefully. So let's start by distributing that k. 3k times k gives us 3k squared. 14 times k is just 14k, so we have a plus 14k. And don't forget we have to subtract that 5 to get it over to the left side. And then we have 0 on the other side. Now I notice that I have a squared coefficient here that's not 1, and I can't factor out a 3 from all this. So that means I'm going to have to use guess and check or the AC method. Let me go with the AC method. So 3 times negative 5, that's negative 15. So I need factors of negative 15 that add up to 14. Well, my only choices are 1 and 15 or 3 and 5. I think I could get a 14 out of a 1 and a 15. If I had a negative 1 and a positive 15, that would add up to positive 14. So I'll split up this 14k into negative 1k plus 15k. And now that I've got 4 terms, I can solve this by factoring by grouping. So for the first 2 terms, I can take out a common factor of k. That leaves 3k minus 1 inside. For the last 2 terms, I can take out a 5, leaving me with 3k minus 1. And since I have a 3k minus 1 in both of these terms, I can take that out as a common factor, leaving me with just k plus 5 as my other factor. Setting each of these parentheses equal to 0 and solving now, because if one of these equals 0, the whole equation equals 0. If 3k minus 1 equals 0, if I add 1 and divide by 3, I get a k value of 1/3. And for k plus 5 equals 0, that means k could have a value of negative 5 as well. So don't forget, we actually have to figure out r minus s. R was the bigger number, s was the smaller one, so that means we're doing 1/3 minus negative 5. And this is really 1/3 plus 5, and to combine these, let me get a common denominator of 3. So I'm going to write this as 1/3 plus 15/3, because that's what 5 can be written as. 1/3 plus 15/3 gives us a grand total of 16 over 3, or 5 and 1/3 if you wanted. To solve by factoring on this one, I need the equation with 0 on one side, and it looks like I've got that. I've also got things in decreasing order of exponents, so this is good. All I have to do at this point is factor and set each factor equal to 0. So one thing I noticed, since we have an a value that's not 1, I have to do a little extra work here, so I'm going to start by checking for common factors. Can I take negative 2 out of everything? Looks like I can. So if I factor a negative 2 out, inside I'm left with x squared, and this will now be minus 6x, and then this negative 16 becomes a plus 8. So factoring this a little bit further, let me bring down that negative 2, and then I need factors of 8 that add up to negative 6. Well, that means they're both going to have to be negative since they multiply to a positive and add up to a negative. So what are my factors of 8? Well, we've got 1 and 8. That's not going to work. 2 and 4 is the only other possibility. And if I had negative 2 and negative 4, that would add up to negative 6. So I can then write x minus 2 and x minus 4 as my two factors. And if all this equals 0, then that means my x values that zero out each of these parentheses are going to be x equals 2 for that first one and x equals 4 for the other one. To solve this equation by factoring, we need to get everything over on one side. So let's do 3x squared minus 5x equals 0. And if I just divide it here by x, as tempting as that is, that would actually lose me a solution of 0. So I can't do that. We have to move everything over here. Now that I've done that, I can factor out the x that I wanted to divide by. That leaves me with 3x minus 5 equals 0. And setting x and this parentheses equal to 0, I get x equals 0 as one of my solutions. If I plug in 0 for x, that zeroes out that whole left side there. And if 3x minus 5 equals 0, well, if I add 5 and divide by 3, I have 5/3 as a solution as well. To solve this one by factoring, I first notice that everything is already in order on one side, so that's good news. I just have to go straight to factoring then. And I notice I have an a value that's not 1, so let me take out a common factor if I can. It looks like all of these coefficients are divisible by negative 3. So if I factor out a negative 3, that leaves me with an x squared plus 2x, and then this 9 becomes a minus 3. Let me go ahead and factor a little bit more now, and let me bring down that negative 3 just so I don't lose anything. So for the stuff inside here, I need factors of negative 3 that add up to 2. Well, if we had, let's see here, 1 and 3 is really our only choice. Negative 1, positive 3 would do it. So I could write x minus 1, x plus 3, and all of that equals 0. Setting each of these factors equal to 0 and solving now, well, negative 3 is not going to give us anything because it's a constant. It can never equal 0. But x minus 1 could be 0 if I had an x value of 1. And x plus 3 can equal 0 if x equals negative 3. To solve this equation by factoring, I need to get everything on one side of the equation. So let me just subtract this 2 over here to the left side. That leaves 0 on the right side. And I have an a value here that is not 1. So if I try to take out a common factor, I notice that I can't do that. So that means I'm going to have to use either guess and check or the AC method. I'm going to go with the AC method here. 4 times negative 2 gives me an AC value of negative 8. So I need to find factors of negative 8 that add up to positive 7. Well, that shouldn't be too bad. What are our factors of 8? We've got 1 and 8 and 2 and 4. If I had negative 1 and positive 8, that would add up to positive 7. So I'm going to split up this 7x into negative 1x and positive 8x. And now that I've split this whole equation, or at least the left side, into 4 terms, I can use factoring by grouping to continue. So taking a look at the first 2 terms here on the left, I can take an x out of both of those. That leaves me with 4x minus 1. And for the next 2 terms, I can factor out a 2, leaving me with 4x minus 1. I can factor out the 4x minus 1 as a common factor, and that leaves me with x plus 2 in another parentheses. And now setting each of these parentheses equal to 0 and solving, for this first one, 4x minus 1, I would have to add 1 and then divide by 4 to solve that equation. So that would be a value of 1/4 that zeroes out this first parentheses. For the second parentheses, I would just have to subtract 2, so then x equals negative 2 for that second solution. To solve this equation by factoring, let me first add this 3 over to the left side so that I've got this whole thing zeroed out. And now if I factor it and set each factor equal to 0, that will allow me to solve for x. So I see here that I have an a value that's not 1, and I can't take out any common factors, so let me use the AC method or guess and check to figure out the factorization. I'm going to go with the AC method. 4 times 3 for my AC value is going to give me 12. Now I'm just looking for factors of 12 that add up to this middle value here of 8. And if I had 1 and 12, that wouldn't work. 2 and 6 would work, though. So I can split up this 8x into 2x plus 6x. And now that I've done that, I can factor by grouping. So let me take a 2x out of those first two terms. That leaves me with 2x plus 1. And then for the second two terms, I'll take out a 3, leaving me also with 2x and plus 1. Now I can factor 2x out of everything. That leaves me with 2x plus 3 as my other factor, the leftovers. And now I have to set each of these factors equal to 0 and solve. Well, if 2x plus 1 equals 0, if I subtract 1 and divide by 2, I get an x value of negative 1 over 2. If 2x plus 3 equals 0, if I subtract 3 and divide by 2, well, now I have an x value of negative 3 halves.